All right, what's going on, everybody? My name is Reginald Cuthbert. Most people call me Mr. C, but today I'm here representing Toolbox Tutors, and I'll be giving you live tutoring here on Facebook. So what we'll do today is we'll go ahead and start off with a couple of questions that we have and work through the misconceptions that I've seen that a couple of students have had and students often struggle with throughout the year. So first, let me share my screen. And we'll go to pull this up. All right. So here what we have is a word problem where they want us to write an equation in slope-intercept form to model this situation. So it says you're renting a bicycle for $20 plus $2 per hour. So first, the key pieces of information that we have is that we have the flat rate of $20. So we know we're going to have to pay $20. After we pay that $20, from there we have to pay $2 per hour. That's a horrible outline, but you get what I'm trying to show you. So we're starting off with $20. $20. And you have to pay $2 per hour. So this would be 2x. Since we're adding these two, it has plus right here. This would give us plus. So our final answer would be y equals 2x plus 20. Again, what this represents is the $2 per hour. That's your 2. And the 20, this is your flat rate, meaning that you're going to have to pay this $20 regardless of what you do with the bike. Even if you get the bike for $1, you're going to have to pay the $20 off in the beginning, but also the $2 for that hour. So let's take this a little bit further. Let's look at this, and X represents our hours, and Y represents our total. So we have a total. So now we have 1, 2, 3, 4, 5. And actually I put 0 on here also. So we got 0, 1, 2, 3, 4, 5. All right. So for 0 hours, let's just say you want to call in and say you want to rent the bicycle, but you never go pick it up. Let me shrink the screen a little bit, slide it over so it'll be a little easier to see. And say you don't go pick it up. What you have is you're going to pay $2 times 0 because you're not picking it up, but that $20 you're using to even rent the bicycle, you still have to pay. So even if you register to rent this bicycle or you reserve this bicycle and you don't go pick it up, you'll still have to pay $20. Now from here, what happens is, let's just say you decide to get the bike, but instead of, and you decide to keep the bike for 1 hour. So you have the $2 times 1 hour plus the $20 you have to pay in the beginning. So order operations tells us to start with multiplication first. So we have 2 times this 1 gives us 2. And 2 plus this 20 gives us 22. So that'll be $22. Now let's That's a pretty easy pattern to catch on to. So let's skip from, we'll try 2 and then we'll skip from there and try a bigger number. Let's see what it would be if you want to run it for a day. So now for 2 hours, you have the $2 fee for the hour. The amount of time is 2 hours plus the 20 that you have to pay just to get the bike. So 2 times 2 gives you 4, plus the 20 gives you a $24 total you have to pay for 2 hours. So now let's say you're going on a trip and you decide to keep the bike for 24 hours. So if you're going to keep this bike 24 hours, guess what the only thing is going to change in this whole function here? The number in the parentheses, right? So there are 24 hours. We have $2 times this 24 plus 20. Now, some of you may not know off the top of your head, but we can use our calculator and we get 2 times 24. That gives you a total of 48. And then we're going to add that to the $20 flat rate that we have to pay. So from here, 48 plus 20 gives us $68 that you would have to pay to keep it for the whole day. All right. So now that's our first question. So now we'll go on to the next question. Let's see. All right. So our next question we'll be picking up is, this is a Algebra 1 standard, and we'll be looking at you solving this using the quadratic formula. So let me shrink this a little bit because we're going to need some space for this. All right. So first, before we begin, since I know we're using quadratic formula, I'm going to write quadratic formula on the screen so we'll have this formula to refer back to. So we have, and I'm going to write what we're working on, quadratic. So we have quadratic formula. All right, so the quadratic formula is negative b plus or minus square root b squared minus 4 times a times c all over 2a. So now the first thing we want to do when we're dealing with this function right here is we want to make sure it's in standard form. Now, standard form is when we have all of our terms on one side of the equal and it's set equal to 0. So the first thing you want to do is get rid of this negative 10 and move it to the left side of the equal so that we have everything on one side. So now we add 10 here. And if we're looking at these 3 terms, this 1, 2, and 3, of those 3 terms, the like term with this 10 would be 13. So we'll add this 10 to this negative 13. The rest of our terms, we could just bring these down. So 2m squared, we have nothing to add with that. So we have 2m squared, horrible 2. We bring down also our negative 7m, but negative 13 plus 10, that gives us negative 3. And on the right side, negative 10 plus 10 gives us 0. And now we have this quadratic in standard form. Now from here, notice that when we wrote out the quadratic formula, we have letters and not numbers. What we need to do is identify the letters or the variables that we'll be plugging in for those values. So as long as you have this in standard form, you can always remember whatever's in front of your squared term, that will be a. whatever's in front of your b, whatever's in front of your linear term or your regular variable, that will be your b, and your constant at the end will be your c. And just to make sure we keep the signs with it, I'll write it out. So we have a equals 2, b equals -7, c equals -3. So now from here, we'll take these values and we'll actually plug it in to the quadratic formula over here. So in the beginning, we have -b. Now, -b right here is telling us whatever value we have for b, we want to change it to the opposite. So the value we have for b is -7. So what we want to do is change this, and we have the negative of -7 plus or minus sign with the square root. Then we have b squared. Remember, again, we -7 here. So to make sure we put this in a calculator or calculate this right, we're going to put this -7 in parentheses. So we have -7 squared minus 4 times a, which is 2, times c, which is -3. All of this over 2 times a, which is 2. So 2 times 2. So now from here, what we can do is take the value that we have, and we're going to work with this part right. Not what I was trying to do. And we're going to work with the part under the radical first. Let me get this highlighter right. There you go. All right, so we're going to work with this part under the highlighter first. That doesn't go good together, but hopefully you can see it. So under the radical, we have -7 squared minus 4 times 2 times -3. This is another place where your calculator is going to come in handy, because we can solve this by breaking it down and working it piece by piece, or we can use the calculator to help us. So since I have the calculator here, I'm going to use it. So we have open parentheses, -7 squared minus 4 times 2 times -3. And that gives us 73. All right, so we have this equals, and then on the outside, we'll go ahead and work this first too. So negative of -7 simply means that we're changing this to the opposite. So we have 7 on the outside plus or minus square root, and we type all of this into the radical, into the calculator. Under the radical, we have 73 all over 2 times 2 gives us 4. And that would be our answer. Most times you'll see this, and I'll actually take this a step further, because most times if we work out and we get a different answer, most students stop here thinking this means that you have one single answer, when actually this plus or minus sign right, this means something particular and special. What this means is that once you work this out, you're going to be getting 2 different answers. Your first answer would be 7 plus the square root of 73 over 4. And your second answer is, what do you think? Same thing, except you're going to have 7 minus the square root of 73 over 4. And these would be your 2 answers. So either you'll see it written separately like this, where it's 7 plus the square root of 73 divided by 4, and 7 minus square root of 73 divided by 4. Or to keep it simple, you can say 7 plus or minus the square root of 73 over 4. And that would be your answer for this one. All right. So that's that question. Now we'll move on to the next one. Let's see. Let's look at factoring. So for this one, once again, we are dealing with quadratics. But for this quadratic function, or this quadratic expression, we'll be solving this by simply using the method of factoring. So this is factoring. Factoring. All right. So we're solving this by factoring. What we want to do is identify the factors of 8 that can add up to give us -9. To break this down into parts, let's first just list the factors of +8. So I'll write this 8 over here to the side. And I need to find what numbers can I multiply to get 8. So first we have 1 times 8. And this is a +8, so I want to remember that. And we also have 2 times 4. But remember, when we're dealing with this, we also have another way of getting a positive answer when we multiply two numbers together. We can either multiply positive times positive, or we can multiply negative times negative. So what we'll do is use these exact same terms, since these are the only numbers we can multiply to get 8, but we'll make them both negative. So we have -1 times -8, and also -2 times -4. So now these are all the factors we can use to multiply and get +8. So now from here, what we want to do is identify which of these factors can we put together and get a -9 when we put them together. So let me get a different color so this will kind of stick out. So over here to the side, we have 1 plus 8, since both of these are positive. Now 1 plus 8 gives us +9. What we're trying to get is a -9, so this won't work. Next, we have 2 plus 4. Once again, 2 plus 4 gives us 6, which is not the negative, and it's a +6, which is not the -9 we want. So we'll go on to the next term. Here we have -1 minus 8. -1 minus 8. Both of these have a negative sign, so we keep the negative, and then 1 plus 8 gives us 9, and this gives us -9. And just to show you that the other one won't work, we'll write this one out. -2 minus 4, that gives us -6. Now of these 4 pairs of factors, the only one that works is this third one right here. So we know that of those factors, this will be the group that we're using. So from here, we have our factors we'll be using, and we're going to set up 2 sets of parentheses. So first we have -1 here, and we have -8 here. Now you may be wondering, or you may have forgotten what goes in the front of the parentheses. Well, we have this m squared here. What we want to do is, just like with the 8, we want to identify what can we multiply to get m squared. And the only thing we multiply to get m squared is m times m, or m squared times m, but m squared times 1, but that won't work in this case. We have m times m. So we have m right here in this parentheses, one will go there, and one will go here. Now we're looking at this, and you may say, well, I don't know if I'm right. How can I check this answer? Well, I'll show you. So what we can do is take our answer and actually work backwards, just like we're multiplying polynomials. So we'll be using the FOIL or the distributive method, and we'll multiply m times m. So m times m. Next we can m times -8. That'll be m times -8. Then we'll multiply -1 times m, -1 times m, and then we'll multiply -1 times -8, -1 times -8. And from here, we'll simply work these out. So let me pick a different color so all this won't be jumbled up together. Purple work. So m times m gives you m squared. 8 times negative m times -8 gives you -8m. -1. Let's see. -1 times m. That gives you -1m. And -1 times a -8 gives you a +8. From here, we'll combine like terms. So of all of these terms, we have these two as like terms. So now -8 m minus 1m equals, they have the same sign, so negative, and 8 plus 1 gives you 9. So our answer will be -9m. So now we simply take our pieces, put them together, and what you'll notice is that we have the same answer that we started with. So we have this. I'll use a highlighter for this. We have this. That's not a highlighter. We have m squared, -9m, and +8. So we have m squared minus 9m plus 8. And notice that once we work backwards, we wind up with the same thing we began with, meaning that this answer right here is correct. All right. So next, we'll look at another example. Look at another example. And let's look at unit rate. So now with this question, what we want to do is determine which of these is the better buy. Would it be a 12.5 ounce bag of Doritos for $3.79 or a 3 ounce bag for $1? So here we have $3.79, and we also have $1. Now, easy way we can set this up is simply divide the money by the amount that you're going to get in the bag. So what you have is 12.5, and then you have 3 right here. So this is money on top. Let me write this in. So this is the money, and this is the amount or the weight. So money, and this is the amount or weight. So what we can do is, once again, using our calculator, you have 3.79 divided by 12.5. And what that gives you is 0.303. So now we're looking at this in terms of money. We usually don't look at this 3 right here on the end. We usually stop right there. So what we're going to do is take this and cut this off here. So 0.30. And what this represents is up here at the top, we have 3.79. This represents the money. So this would be $0.30 per, use that slash per ounce. And I wrote that out, could use OZ. So next we'll do the same thing with the other bag. So we have a $1 bag that gives you 3 ounces. So 1 divided by 3, that gives you 0.333 repeating. And once again, with money, we cut this off right here with this 3. So 0.33 dollars per ounce. Now we're looking at these two amounts. You walked into the store and you see these two bags. Which one would be the better buy? And by the better buy, I mean cheaper. So in this case, the $3.79 bag would be cheaper because you're paying less per ounce. So the 12.5 ounce bag would be the better buy. Better buy. All right. So that's that one. And then this one, I'll just mark it out. All right. So let's go on to another one. This one, along the same lines, but this one's a little bit easier in my opinion. So you have 192 students in 4 buses. Now, if we want them as even as we can, what we'll do is if we're taking 192 and we're splitting it among 4 buses, the operation for that would be division, because we're taking this number and splitting it. So we have 192, and this would be divided by 4. Instead of using the calculator on this one, I actually worked this one out by hand to just kind of refresh your memory on how to divide. So 4 can go into 19 4 times without going over. So 4 times 4 gives you 16. And once we subtract these, 19 minus 16, that gives you 3. You bring down your 2. So now from here, we want to see how many times can 4 go into 32. 4 can go into 32 8 times. So we have 8. 4 times 8 gives you 32. 32 minus 32 gives you 0. So we have nothing left over. So what this lets us know is that if we have 192 students and we want to split them evenly on 4 buses, that means we have 48 students in each bus. And that's that one. So now let's say if we take this same problem. Let's say if we take this same problem and we actually raise it up a little bit. And we say we have, let me rewrite this. Let's see, 40. 48. All right, so now let's say we have the same situation. We have 192 students, but what we want to do is split them among six buses. We will actually go through the same process. So 6 goes into 1, none, but 6 can go into 19 3 times. 6 times 3 gives us 18, and 19 minus 18 gives us 1. We bring down this 2, and we have 6 going into 12 2 times. So this means if we have 192 students, and we have 6 buses, that means we can put 32 students on each bus. So now that came out even also. So now let's look at this one more example. And let's just say we only had 5 buses. So we have 192 students with 5 buses. How many would get on each bus? Let's work it out. So we have 5 once again, and 192. So now 5 can't go into 1, that's 0. But 5 can go into 19. That'll give us 3. 5 times 3 gives us 15. And once you subtract 15 from 19, you get 4. 5 can't go into that 4, but if we bring down this 2, we get 42. And 5 can go into 42. So 5 goes into 42. 5 times 7 is 35. 5 times 8 is 40. So we have 8 right here, 40 here. And we want to subtract next. So 42 minus 40 gives us 2. We don't have another number here, but what we can do is add a 0 and bring it down to 20. Now we have 5 going into 20 4 times. 5 So we have 2 left over. So what this means, we have 38 with a remainder of 2. So that means 2 students will have to get on one of the 5 buses. So for our answer, we'll have 38 students on how many buses? 38 students on 3 buses. But with this remainder of 2, that means we'll have 39 students on 2 buses. And that will be your final answer for that one. All right. So now let's move on to another question. Properties of exponents. All right. This is another area where I kind of see there'd be a little struggle. So with properties of exponents, what we have to remember is we're dealing with numbers that have the same base but different exponents. In this case, you have in your numerator, we'll just focus on the top, you have 6 and you have 5. So I'll underline this 6. I'll put a box around this 5. So the 6 represents the base. The 5 represents the exponent. Just like here on the bottom, we have 6 and we have 3. 3 is representing your exponent. 6 represents your base. So now to even make this more plain, what I'm going to do is rewrite this a different way. So we have 6 to the 5th power, meaning we're multiplying 6 by itself 4 more times. So we have 5 sixes total. So we have 1 6, 2, 3, 4, 5. And on the bottom, we have 6 to the 3rd power, meaning we have 6 times itself 2 more times, which is 6 times 6 times 6. Now, a way we can eliminate these is using something that we've learned before. So when you have 6 divided by 6, what does that give you? 1, right? So what we can do is if we can mark off a 6 on the top, we can also mark off a 6 on the bottom, and I'll X them out so we can actually see what they still are. So we have 1 6 on top, 1 6 on the bottom, another 6 on the top, another 6 on the bottom, another 6 on the top, another 6 on the bottom. And what we wind up with is just 2 6s on the top. And if we have 1, 2 6s, guess what our answer is going to be? We have the same base, which is 6 to the 2nd power. Now that was the long way. What I do now is I'll show you an even shorter way. So it's to save you a lot of time, especially when you're dealing with bigger numbers and you're not able to write out all of these 6s like I did. So what I did was write this out the long way. Now the shorter way to do this would be simply to have your 6 and we subtract 5 minus 3. And that gives us 6 to the 5 minus 3 gives us 2 to the 2nd power. And notice that we still got the same answer. So now earlier, I guess just a couple seconds ago, I mentioned that this is really more convenient when you're dealing with large numbers, and I'll give you an example. So for this one, we'll be using, let's use 2 to the 20th power divided by 2 to the 9th power. Horrible. 9th power. All right. So once again, we could list 22s out, but that would take a lot of time and a lot of space. But what you notice from the pattern before, we could actually use that instead. So we'll use what we have right here. So we have 2, which is our base, 20, which is the exponent in our numerator, minus 9, which is the exponent in our denominator. Now 20 minus 9 gives us 11. And don't forget to keep that base of 2. And there we have our answer for 2 to the 20th power divided by 2 to the 9th power. So if we divide when we're multiplying, just take a wild guess of what we're doing. If we divide when we're, if we subtract when we're dividing, just take a wild guess of what we're doing when we multiply. We're going to add our exponents together. So as an example, I use this right here, get it off. All right, so we have, let's use 3 to the 3rd power times 3 to the 4th power. So now once again, I could take this, we'll actually write this one out and show you the relationship. So 3 to the 3rd power is saying we're multiplying 3 by itself twice, or we have 3 times 3 times 3. So we have 3 times 3 times 3. From here, we're multiplying, that's this first one. Now for the second one, we have 3 to the 4th power, which means we're multiplying 3 times 3 times 3 times 3. And also multiplying these all together. Now, if we type this in the calculator and we do 3 times 3 times 3, that's first 3 to the 3rd power. And next we have 4 more 3s. So times 3, 1 times 3, 2 times 3, 3 times 3, 4. We get the answer 2187. So that's your answer if you would actually work it out. So this gives you 2187. Now, that's writing all of this out using the long way. There's an easier way. Once again, if we have the same base, which in this case is 3, so we keep our 3, we can simply add our exponents together. So we have 3 plus 4. That gives us 3 to the 7th power. And if we type this into the calculator, 3 to the 7th power, guess what that gives us? 2187. So notice that either way you go, you'll get the same answer. It's just understanding what to do with the pieces that you have helps you move a whole lot quicker. So, for example, instead of having 3 to the 3rd power, let's say I gave you 3 to the 30th power. So 3 to the 30th power times 3 to the 40th power. Now, that number, to write all those 3's out would take too much time. But what we can do, remember the pattern from before, is take these 3, that is the base, that stays the same, and we'll add 30 plus 40. And 30 plus 40 gives you 70. So we have 3 to the 70th power. I won't write that number out because I'm pretty sure that's a pretty big number, but 3 to the 70th power would give you your answer if you want it in exponential form, or if they want it in expanded form, it would be, or simplified terms, whatever the number is that you get once you type that in the calculator, that would be your answer. All right, so next, let's look at properties of exponents again. And this time we're dealing with 2 variables, but don't want you to panic because it's still the same. We're going to use the same tools that we had from before and apply them to this problem here. So once again, we'll split this into 2 pieces actually. So on top, we're going to split this in half. The line should be a little straighter. On the bottom, we're going to split this in half. All right, so we have x's and y split. So over here to the left side, we have x to the 5th power over x. And over on the right side, we have y to the 6th power over y to the 2nd power. So now, after we break this down, makes this a little easier, right? It should. So from here, we can use the tools that we had for x to the 5th power divided by x. And even though there's an exponent written here, there's an understood 1. So we have x to the power of 5 minus 1. So now x to the power of 5 minus 1, that gives us x to the 4th power. So we have this as part of our answer, and I'll write this. I guess I'll just leave it there for now, and I'll come back to it. On the right side, we have y to the 6th power divided by y to the 2nd power. Y to the 6th power, that 6 goes right here. And the 2nd power, we'll just subtract that from here. And y stays the same, but 6 minus 2 can be simplified to 4. So now from here, what we'll do is just take these 2 parts that we have. We'll take this right here and this right here. And this will be our answer when we put these pieces together. So we have x to the 4th. So x to the 4th, y to the 4th as your answer. And that will be it. All right. So now, let's see. 12 ounce. Since we did factoring, let's look at some multiplying polynomials with different variables. So I'll start off with an easier one, and we'll work to a kind of more difficult one since we only have about 8 minutes left. So first we have x plus 2 times y plus 3. So x plus 2 times y plus 3. And over to the right, what I do is I actually put another example just to show you how it's working out the same. It just looks a little different. So we have x plus 2 times x plus 2. So now if we're looking at the one on the right side, we multiply x times x first, and that gives us x squared. Next we'll multiply x times positive 2. That'll give you 2x. 2 times x will give you 2x. And 2 times 2 will give you 2, or 2 times 2 will give you 4. From here, we take our like terms and combine them. In this case, it would be this 2x and this 2x. That gives us 4x. And then we'll take our terms, which is this, to simplify those terms together, that and this. And we have our final answer, x squared plus 4x plus 4. That's your final answer. Now this example over to the left is actually exactly the same. The only difference is you have this y right here, but you're still going to work it out the same. So what we'll do is, let's use black, is we're going to start by multiplying x times y. So x times y, that gives you xy. X times 3, that gives you 3x. 2 times y, that gives you 2y. 2 times 3, that gives you 6. So now we're on the step that we were on at this point right here. And notice that if we look at these 4 terms, so this is 1, 2, it's horrible, arrows. So let me use a different color. So we have 1, 2, 3, 4. If we're looking at these 4 terms, notice that none of these terms are like terms. So since they're not like terms, what we'll do is take each piece and it'll be a term in our answer. So we have, change this. So we have xy plus 3x plus 2y plus 6. And that'll be your final answer. Just like I said before, these two are pretty much the same answer. The only difference is that this one over here on the left doesn't have any like terms like this one does on the right. So that's the only difference. So as long as you know how to multiply terms, multiply variables, and combine like terms, you can multiply binomials or polynomials. All right. Let's see. And let's see, we got 3 minutes left. Get most of your time and giving you some value. We'll work out one more question. Let's see, what can we work on? Let's actually work on something dealing with polynomials again. Except this time I'll try to throw you off by using by using a shape. If I were to give you the shape and I give you the link, the side links of x plus 2, and this is x plus 9, and I'll say 2x plus 9. And I ask you to find the area. So I'm going to write this up here, area. How could we find the area? Don't let it confuse you, because just like if these numbers weren't here, so I'll take this and slide this over. And I'll just take this same shape. The only thing I'm going to do here is I'm going to change this to a 2 and change this to a 9. If I ask you to find the area, how would you do that? Simply just multiplying 2 times 9. 2 times 9 gives you 18. But that's actually what we're doing over here, except we're going to apply what we did with the last problem. So we have x plus 2 times 2x plus 9. And that'll give you the area of the shape. So it's 459. We're going to end. Don't forget that if you have any other problems that you need help with, don't forget to send us a picture on Instagram or Facebook. If you have any videos you'd like us to make notes on or do a guided example with, please send it to us. We can put it up on YouTube. Don't forget to check out the videos we already have up, because we cover a lot of the stuff that we did today. We actually have videos on it. We have videos on simplifying radicals with square roots, cube roots, adding and subtracting cube roots and square roots, multiplying binomials, graphing linear functions, just a lot of stuff. But if you need any more help, don't hesitate to contact us at Toolbox Tutors on Facebook, Instagram, and YouTube. See you next time.